The Moselle River flowed swift and dark that early September evening in 1944, its waters reflecting the dying light as Colonel Friedrich von Mellenthin stood watching something that shouldn't have been possible. As Chief of Staff to General Hermann Balck's Army Group G, Mellenthin had seen considerable action across multiple theatres, but what unfolded before his eyes along the eastern bank near Pont-à-Mousson defied everything his military education had taught him about river warfare and defensive operations. American engineers swarmed across the water like industrious ants, their bridge taking shape with a speed that seemed almost supernatural to the veteran German officer. When Mellenthin sat down to compose his entry in the operations diary later that night, his pen moved with unusual urgency across the page. The words he chose would reveal just how deeply the Wehrmacht's command structure was beginning to grasp the magnitude of what they faced. He wrote that the enemy's capacity to construct bridges had exceeded every calculation their intelligence had made. The Americans weren't just building one crossing at a time and moving on. They were establishing multiple crossings simultaneously across vast stretches of river, completing their construction work before German artillery could even range in properly and deliver effective counter-battery fire. This wasn't warfare as the Germans understood it. This was something entirely new. What that experienced staff officer witnessed represented far more than just efficient engineering work. Across a front stretching more than 800 miles from the Swiss border to the English Channel, American engineer battalions were engaged in a systematic demonstration that would fundamentally alter how modern armies approached river obstacles. The Wehrmacht's doctrine, refined over centuries of European warfare and validated countless times on the Eastern Front, held that major rivers represented natural defensive barriers that could channel enemy movements and provide time for reorganization. That doctrine was becoming obsolete before German eyes, rendered irrelevant not by some brilliant tactical innovation, but by sheer industrial capacity married to organizational flexibility. Between August of 1944, when the breakout from Normandy gathered momentum, and May of 1945, when the war in Europe finally concluded, American engineers would construct more than 300 major river crossings. Each bridge represented not just a tactical victory, but a strategic hammer blow against German defensive planning. German intelligence officers, working with increasingly incomplete information as their reconnaissance capabilities degraded, initially managed to track 119 bridges during Patton's autumn offensive alone. That number seemed impossibly high until subsequent weeks saw it surpassed again and again, the totals climbing to levels that made German staff officers question whether their own counting methods had gone wrong. General Hermann Balck commanded Army Group G, defending the approaches to southern France and the Reich's western borders. His credentials were impeccable by any military standard. He had earned the Knight's Cross with oak leaves, swords and diamonds, one of Germany's highest military decorations, for his service on the Eastern Front. There, he had demonstrated tactical genius of the highest order, destroying entire Soviet tank armies during the savage fighting along the Chir River. Balck was no amateur, no garrison officer promoted beyond his competence. He was a panzer commander who understood mobile warfare at its most visceral level. Yet in his post-war interviews, conducted when the bitterness of defeat had faded enough to allow honest assessment, Balck admitted something remarkable. His forces had prepared defensive positions along the Moselle for weeks, digging in, sighting artillery, creating interlocking fields of fire. Traditional military science, validated by hundreds of years of European warfare, indicated that such a river barrier would hold an attacking force for at least 2 weeks. The Americans crossed it in 2 days. The revolution that Mellenthin and Balck were witnessing hadn't materialized overnight. Its roots stretched back months earlier to Normandy, where American commanders at every level were learning lessons about mechanized warfare that would transform their operational thinking. General George S. Patton, newly appointed to command Third Army as that formation became operational, understood one principle with crystalline clarity. In modern mechanized warfare, maintaining momentum was absolutely paramount. Once an enemy was reeling, once his defensive coherence shattered, the attacking force had to maintain relentless pressure. Any pause, any hesitation, gave the enemy time to recover, to reorganize, to establish new defensive lines. But Patton grasped something that went deeper than this tactical truism. Momentum without logistics was worse than meaningless. It was suicidal. An army that outran its supply lines became a collection of immobilized metal boxes waiting to be destroyed. In Europe's terrain, crisscrossed by countless rivers and streams, logistics meant one thing above all others: bridges. On July 31st, 1944, one day before Third Army officially became operational and began its rampage across France, Patton assembled his engineer commanders at a forward position near Avranches. Among those present were Colonel Garrison Davidson, who served as Third Army engineer, and Lieutenant Colonel George Walker of the 1139th Engineer Combat Group. Both men were experienced officers who had trained extensively for this campaign, but neither had worked directly with Patton before. They were about to receive an education in what their new commanding general expected. Patton's directive was characteristically direct, stripped of unnecessary military jargon, and delivered with the force of absolute conviction. He told his engineers that the Germans would destroy every bridge between their current position and Berlin. That was a given. The German army was many things, but it wasn't stupid, and scorched earth tactics along the retreat route were standard doctrine. The engineer's job, Patton explained with brutal simplicity, was to replace those destroyed bridges so fast that the enemy wouldn't even know where to concentrate their artillery fire. He wanted them to make geography itself irrelevant, to transform every river from an obstacle into merely another feature to be crossed and left behind. The American engineering advantage didn't spring fully formed from wartime necessity. Its roots ran deep into the peacetime training establishment. Since 1942, the United States Army had undertaken a complete revolution in how it trained combat engineers. At Fort Belvoir's engineer school in Virginia, entire battalions cycled through training programs that would have seemed excessive to European military observers. They practiced rapid bridge construction under every conceivable condition that training officers could devise. Squads assembled heavy Bailey Bridge panels blindfolded, learning the components by touch alone. They worked in freezing water that left their hands numb and unresponsive. They completed construction exercises under simulated artillery fire, with training cadre throwing smoke grenades and setting off explosives to approximate combat conditions. Technical Sergeant Robert Shalato, who served with the 249th Engineer Battalion through the European campaign, recalled years later how intense that training had been. They worked 7 days a week, he said, often conducting night exercises when exhaustion made every task harder. A good squad, properly trained, could connect bridge panels in complete darkness purely by touch, their hands finding bolt holes and securing pins through muscle memory alone. When these men finally reached actual combat conditions in Europe, Shalato observed, the work was almost automatic. Their hands knew what to do, even when their minds were processing the terror of incoming artillery fire. The material advantage American engineers enjoyed was equally decisive. American industry had embraced the challenge of mass-producing bridging equipment on a scale that no other nation could match. The Bailey Bridge, originally a British design that had been licensed for American manufacture, revolutionized military bridging in ways that are hard to overstate. Each bridge consisted of 10-foot steel panels, each panel weighing roughly 600 pounds. These panels could be assembled entirely by hand, without requiring cranes or other heavy lifting equipment. By the time the war ended, American factories had produced enough Bailey Bridge components to span the English Channel more than 50 times over. That represented hundreds of thousands of tons of precision-manufactured steel, all of it shipped across the Atlantic and distributed throughout the European theatre. The M2 Treadway Bridge represented pure American innovation. This system consisted of pneumatic floats that supported steel decking sections. The entire bridge could be assembled directly from the trucks that carried it, requiring minimal preparation of the riverbanks. The 991st Engineer Treadway Bridge Company, through repeated practice and refinement of their techniques, could construct a 540-foot bridge capable of supporting 40-ton Sherman tanks in under 4 hours from the moment they arrived at the river until the first tank rolled across. Captain Hans Müller, a Wehrmacht pioneer officer who was captured in December of 1944 during the Battle of the Bulge, provided intelligence that confirmed what American commanders already suspected. During his interrogation, Müller explained that the best German engineer battalion, operating with all necessary equipment available and facing no enemy interference, required 48 to 72 hours to construct a heavy bridge capable of supporting armoured vehicles. The Americans, he noted with something approaching disbelief, accomplished the same task in 4 hours while under active artillery bombardment. They weren't fighting the same war, Müller concluded. The technological and organisational gap was that profound. The crossing of the Seine River in late August of 1944 provided the first major demonstration of what American engineering capabilities could accomplish under combat conditions. The German 7th Army, withdrawing in disorder after the Falaise pocket collapsed, had systematically destroyed every bridge along a 60-mile front. General der Waffen SS Paul Hauser, commanding the shattered remnants of his forces, calculated that the Americans would require at least 10 days to force a crossing of the Seine in strength. His engineers had done thorough demolition work, and the river presented a formidable obstacle. Instead, the 1,139th Engineer Combat Group threw 5 complete bridges across the Seine in 72 hours. At Malone, engineers from the 537th Light Ponton Company constructed a footbridge while under direct fire from German machine gun positions on the far bank. An 88mm shell, fired from a self-propelled gun that German gunners had carefully concealed, scored a direct hit that destroyed a 50-foot section of the bridge even as construction continued. The engineers simply rebuilt that section while continuing to work on the rest of the span. Private Lawrence Jefferson, who received a Bronze Star for his actions during this operation, described the intensity years later. German shells were landing in the water all around them, he said. When one blew out a section they had just completed, they simply rebuilt it without discussion. They had to keep working because the infantry needed that bridge. Men were dying trying to cross by boat, and every hour without a bridge meant more casualties. The sophistication of American river crossing operations extended far beyond simple speed of construction. The 161st Chemical Smoke Generating Company could blanket an entire river valley in dense smoke within minutes of being called forward. Counter-battery radar units, a technology the Germans never deployed effectively, could immediately locate the precise position of German guns the moment they fired. This information was relayed instantly to American artillery, which delivered devastating counter-battery fire with accuracy the Germans couldn't match. Lieutenant Wilhelm Hoffmann, serving with Artillery Regiment 17, tried to explain the frustration to his interrogators after capture. They would spend hours calculating firing solutions, getting range and bearing perfect. Then suddenly, without warning, thick chemical smoke would cover everything. They fired blind through the smoke, hoping to hit something. When the smoke finally cleared hours later, completed bridges with tanks already crossing them would be facing German positions. The Moselle River operations throughout September of 1944 demonstrated the full extent of American engineering dominance. The river presented truly formidable obstacles to any attacking force. It ran more than 200 feet wide in most places, too wide for simple expedient bridging. Its banks rose steeply from the water, complicating the approach routes engineer units would need. The current flowed swift and treacherous, capable of sweeping away floating bridge sections if they weren't properly anchored. Most significantly, the Germans had spent weeks preparing extensive fortifications along the eastern bank. General Balck had positioned his 47th Panzer Corps along the Moselle with complete confidence that the river would halt Patton's advance for a significant period. During a staff conference on September 5th, attended by his division commanders and senior staff officers, Balck declared with absolute conviction that the Americans were excellent soldiers. No one could deny that, but they were not superhuman. The Moselle would stop them just as rivers had stopped armies throughout military history. Physics and geography didn't care about industrial production or tactical innovation. What followed shattered German assumptions so completely that Balk's staff initially reported the results incorrectly, unable to believe their own observations. At numerous points along the river, American engineers constructed bridges under fire with speed that seemed to violate natural law. German artillery officers, trying desperately to interdict these crossings, found that tasks which would have taken their own engineers 3 days were being completed by the Americans in 3 hours. Field Marshal Gerd von Rundstedt, overall commander of German forces in the West, reported directly to the Führer on September 10th. His message was stark and unambiguous. The enemy possessed a bridge-building capacity that completely negated traditional defensive planning built around river obstacles. They were crossing water obstacles faster than German forces could shift reserves to threatened sectors. The operational tempo was simply too fast for the Wehrmacht's command structure to respond effectively. Technology amplified American advantages at every turn. Massive D7 bulldozers, products of Caterpillar's wartime production, could clear away the debris of demolished bridges in roughly 2 hours. Tasks that would have required hundreds of men working with hand tools were mechanized and accelerated. Truck-mounted air compressors could inflate pontoon bridge floats in minutes rather than the hours required by hand pumping. Every piece of equipment American engineers employed was standardized across units, completely interchangeable. This meant that any engineer company could effectively employ equipment from any other company without retraining or adaptation. Master Sergeant Earl Hall, serving with Company B of the 1303 Engineer General Service Regiment, explained the philosophy years later at a reunion. Everything was about time, he said. Time was lives. Every hour without a bridge meant more infantrymen dying, trying to force a crossing by boat or swimming. So the engineers developed systematic approaches to everything. Parts were numbered in logical sequences. Tools were color-coded so men could grab what they needed, even in darkness or smoke. Laminated instruction cards, waterproofed and attached to equipment, provided step-by-step procedures. A replacement fresh from the States could arrive, receive an hour of orientation, and contribute effectively to bridge construction within hours. The human cost of this operational tempo was severe. Engineers worked completely exposed to enemy fire by the very nature of their mission. During the Moselle crossings alone, engineer units suffered 15% casualties. At the Saar River in December, where German resistance stiffened considerably, the 994th Engineer Treadway Company lost 18 men killed or seriously wounded in a single hour. They continued construction without pausing, replacements stepping into the positions of fallen comrades and carrying on the work. Lieutenant Colonel Kenneth Fields, commanding the 135th Engineer Combat Battalion, was wounded by shrapnel during bridge construction near Metz. The fragment caught him in the shoulder, a serious wound that required immediate medical attention. Fields refused evacuation for 6 hours, remaining on site and directing operations until the bridge was complete and operational. His words to the medics who tried to pull him off the line became legendary among engineer units. "The infantry needs this bridge tonight," he told them, "not tomorrow. We finish what we start." Only after the first Sherman tanks rolled across did Fields allow himself to be evacuated to an aid station. German combat engineers, the Wehrmacht's pioneer troops, developed profound respect for their American counterparts despite being enemies. Major Friedrich Schulze of Pioneer Battalion 305, captured during the Rhine crossings, told his interrogators something revealing. The Germans had thought Americans were soft, he admitted. Propaganda had painted them as cowardled materialists who would break when faced with real hardship. But American engineers stood in freezing water for hours at a time, worked through artillery barrages that would have sent infantry units running for cover. They had unlimited equipment, yes, Schulze acknowledged, but they also possessed unlimited determination, a willingness to stand and complete the mission regardless of cost. The Rhine crossing operations in March of 1945 represented the culmination of everything American engineers had learned and refined over 8 months of continuous operations. The capture of the Ludendorff Bridge at Remagen on March 7th was partially fortunate, the result of German demolition charges failing to completely destroy the span. But what happened next revealed American adaptability and determination. Despite concentrated German artillery fire, air attacks by what remained of the Luftwaffe, and even experimental V-2 rocket strikes aimed at the bridge, American engineers immediately began constructing supplementary bridges. When the damaged Ludendorff Bridge finally collapsed on March 17th, killing 28 American engineers who were working to strengthen it, 8 additional bridges already spanned the Rhine at Remagen. Patton's crossing at Oppenheim demonstrated deliberate American engineering might divorced from any element of luck. On the night of March 22nd, without any preliminary bombardment that might alert German defenders, the 5th Infantry Division crossed the Rhine in assault boats. By dawn on March 23rd, while German commanders were still trying to understand where the crossing had occurred, engineers had completed a 1,000-foot heavy pontoon bridge. Within 48 hours, 3 major bridges were carrying Third Army's full weight across the Rhine. Colonel Hans Felber, who had served as chief engineer of Army Group B, was captured in April as German resistance collapsed. During his interrogation, he tried to make American intelligence officers understand the psychological impact of facing such engineering capability. The Germans were excellent engineers, Felber insisted. That wasn't false modesty. Their training was thorough, their technical knowledge solid. But American engineers operated according to completely different principles. They brought industrial production methods directly to the battlefield. While German engineers carefully calculated load-bearing requirements and stress points, American engineers were already driving tanks across completed bridges. The gap wasn't just technological, it was philosophical. The statistics from March 1945 alone told a remarkable story. American engineers constructed 62 bridges across the Rhine and its tributaries in a single month of operations. The longest, a 1,900-foot Bailey Bridge constructed at Wessel, was completed in 9 hours and 30 minutes, despite continuous German fire from positions across the river. These bridges, built under fire and maintained under attack, carried more than 1 million men and 300,000 vehicles into the heart of Germany. Beyond bridges, American engineers were transforming the entire battlefield environment. They constructed 17,000 miles of roads, often from scratch through terrain that had never seen paved surfaces. They cleared millions of mines, painstaking and terrifying work that claimed hundreds of lives. They built 121 airfields, some capable of handling heavy bombers. They repaired 8,000 miles of railroad track, restoring the very transportation infrastructure German forces had spent months destroying. The organizational philosophy undergirding these achievements proved absolutely crucial. American engineers operated with remarkable autonomy compared to their German counterparts. A sergeant in an American engineer company could make tactical decisions that would have required a captain's explicit approval in the Wehrmacht's rigid hierarchy. This decentralized decision-making, combined with completely standardized equipment across all units, created unprecedented flexibility at the tactical level. Colonel Wilhelm Wegener, who had served as Chief of Staff of the German 5th Panzer Army, observed something profound about this difference during his interrogation. The American Army, he told his captors, was an industrial democracy in uniform. Every soldier understood the overall mission and could act independently to achieve objectives. The German army, by contrast, remained fundamentally aristocratic in structure. Orders flowed downward through rigid hierarchies. Initiative at lower levels was actively discouraged as a threat to command authority. This difference had enormous operational consequences. Traditional defensive doctrine, validated across centuries of warfare, assumed that major rivers provided time for defending forces to reorganize. River crossings required extensive preparation, careful reconnaissance, time-consuming construction of bridges or assembly of boats. This predictable timeline gave defenders opportunities to shift reserves, concentrate artillery, prepare counterattacks. American engineering capabilities eliminated that assumption entirely. General Hasso von Manteuffel, one of Germany's most capable panzer commanders, tried to explain this to post-war interrogators. In previous wars throughout European history, he said, reaching a major river meant an operational pause was inevitable. Armies had to stop, bring up bridging equipment, conduct reconnaissance, plan the crossing. Against the Americans, no such pause existed. They pursued across rivers as if rivers were merely lines drawn on maps, completely irrelevant to operational planning. The impact on German morale extended beyond the combat units. Young Wehrmacht soldiers, many of them conscripts with minimal training, watched American engineers constructing bridges under artillery fire that German engineers couldn't have built even in peacetime without such pressure. Lieutenant Martin Jennings, writing from a prisoner of war camp after his capture, tried to explain what this did to German soldiers' confidence. They had been told repeatedly by propaganda that Americans were cowards who relied entirely on material superiority to compensate for personal weakness. But Jennings had personally watched American engineers working in the open while shells fell among them. When one man was hit and fell, another immediately took his place without any hesitation or discussion. This wasn't cowardice. This was something much more dangerous to German hopes. German civilians in towns along the Rhine witnessed bridges appearing overnight as if by magic. Anna Richter, a schoolteacher in the town of Worms, kept a diary throughout the final months of the war. Her entry for March 25th recorded American vehicles crossing a bridge that hadn't existed the previous day. All day they crossed, she wrote, vehicle after vehicle in an endless stream. Her father, a veteran of the Great War who had fought at Verdun, watched silently from their window. Finally, he spoke. Germany has challenged a giant, he told his daughter. The full meaning of that statement wouldn't become clear until years later, but in that moment, watching American power flow across a bridge built in hours, its truth was undeniable. The initial 119 bridges that German intelligence had tracked during the autumn offensive represented just the opening movement of a symphony of construction. By the time the war ended in May of 1945, American engineers had constructed more than 300 major bridges across rivers throughout Western Europe. They had fundamentally changed the nature of warfare in ways that would influence military thinking for generations. In his final report, written in the bunker before he took his own life, Wilhelm Keitel tried to summarize what had gone wrong with German defensive planning. The enemy's technical superiority, he wrote, especially in engineer capabilities, had made traditional defensive warfare completely impossible. German defeat had become inevitable from the moment this reality became clear to senior commanders. They had been fighting a 20th-century war with 19th-century assumptions about how terrain constrained operations. Post-war analysis by American strategic bombing survey teams confirmed Keitel's assessment. While air power and armoured forces received most of the public attention and historical focus, combat engineers were possibly the single most decisive arm in defeating Germany. The ability to maintain operational momentum regardless of terrain features had proven absolutely critical. General Franz Halder, former chief of the German General Staff who had been removed from command and imprisoned after the July 20th plot against the Führer, wrote extensively about the war after his release. The American engineer, he observed, represented something genuinely new in military affairs. They embodied the marriage of industrial production capacity with combat capability. Every bridge they constructed brought the factories of Detroit and Pittsburgh one river closer to Berlin. Geography had ceased to be destiny. For American engineers who survived the war and returned home, their achievement remained a source of lifelong pride. Staff Sergeant James Patton of the 249th Engineers, speaking at a unit reunion in 1995, tried to put their accomplishment in perspective. They weren't heroes, he insisted. Heroes were the men who charged machine gun positions, who threw themselves on grenades to save their comrades. The engineers just built bridges. But Patton acknowledged that every bridge they constructed meant American soldiers got home sooner. Every river crossed quickly was one less defensive line the Germans could establish, one less week or month of war. The legacy of American engineering operations transcended individual memories and veteran reunions. NATO doctrine, developed during the early Cold War years, incorporated lessons learned from these river-crossing operations. The Bundeswehr, West Germany's rebuilt military, emphasized combat engineering to a degree that would have been unimaginable in the Wehrmacht. Colonel Hans Speidel, who had served as Rommel's chief of staff and later became a NATO commander, wrote about this transformation. The Americans taught European militaries that in modern warfare, the side that maintains momentum wins. Momentum requires mobility above all else. Mobility requires engineers. This wasn't a minor tactical detail. It was a fundamental truth of industrial age warfare. The story of those bridges, stretching from the Seine to the Elbe, reverberates through history as testament to what American industrial democracy could accomplish when fully mobilized for war. Those 119 bridges that German generals never expected to see became powerful symbols of a fundamental truth about modern conflict. In industrial age warfare, production capacity and organizational flexibility trump traditional military virtues like courage and tactical skill. Those qualities remain important, certainly, but they cannot overcome massive material and systemic advantages. Young Americans, farm boys from Iowa who had never seen anything larger than a creek, factory workers from Detroit who understood industrial processes, college students from California who brought theoretical knowledge to practical problems, had taken American industrial might and applied it directly at the sharp end of warfare. They didn't just win a war, though they certainly did that. They revolutionized how future wars would be conceived and fought. German generals who had dismissed American engineers as mere construction workers, technicians rather than real soldiers, witnessed those engineers fundamentally reshape European terrain to suit American operational needs. Rivers that had stopped armies since Roman legions first marched north across the Alps became brief delays measured in hours rather than days or weeks. The very geography of warfare had changed. The deeper story is really about American democracy at war, about what happens when a free society with massive industrial capacity decides to apply all its resources toward a single goal. That society was messy by German standards, decentralized to the point of seeming chaos. But it was also flexible in ways hierarchical societies could never match. It was innovative because it allowed and encouraged innovation at every level. Most importantly, it was backed by industrial productive power that seemed unlimited from a European perspective. German generals, trained in a military tradition stretching back to Frederick the Great, had no framework for understanding an army where a sergeant with a bulldozer and a stack of bridge panels could reshape the battlefield to suit immediate tactical needs. Their entire conception of military operations assumed that certain decisions had to flow through command hierarchies, that certain capabilities resided at division or corps level. The American Army flatly rejected these assumptions, pushing capability and decision-making down to the lowest practical level. Each bridge American engineers constructed carried a message to German defenders watching from their positions. That message said American productive capacity was effectively limitless, that American determination was unbreakable, that the war's outcome was inevitable because Germany simply couldn't match what America could bring to bear. The engineers weren't just building river crossings. They were building the pathway to a new era in warfare, an era where industrial might and human ingenuity working together could trump terrain, weather, defensive positions, everything that had constrained military operations throughout history. Those German generals who never expected to see engineers throwing up bridges while Patton's tanks thundered forward across them learned the arithmetic of modern warfare too late to matter. The combat engineer had evolved into something as essential to victory as any warrior who ever took the field throughout human history. These men with their bulldozers, their bridge panels, their pneumatic floats and steel decking faced not just an enemy army, but represented an entire system of warfare that literally built its way to victory one bridge at a time across 800 miles of front.